Hi, I'm Larry Johnson. I'm a professor at Texas A&M University, and today we're going to talk about skin.
Hello, I'm Larry Johnson. I'm a professor at Texas A&M University, and today we're going to talk about skin. The first presentation has to do with the functions of skin, the origin of skin, the epidermal-dermal interactions, and the dermal glands and nerve endings.
Our objective is to gain a greater appreciation for the diversity of functions of skin and to recognize the different cell types and structures of skin that make possible this functional diversity. Now, what is the function of skin? It protects us against injury. You see this little boy has injured his leg. It also prevents against desiccation. We are terrestrial beings. We live on the land. We don't live in the sea because we do not desiccate. And our skin maintains that, maintains water balance, excretes substance, thermal regulations. It receives temperature, pain, as that little boy is experiencing, and pressure. Also, skin is a basis of recognition, and it yields clues about one's well-being. You can look at these two ladies and tell right off which one is the daughter and which one is the mother. Also, fat metabolism in the subcutaneous or hypodermis layer, this fat here, is an energy source for metabolism. Now, skin has a binary origin. There's three origins: ectoderm, mesoderm, and endoderm, and two of those is where we get skin. Ectoderm is the epidermis, and the dermis come from the mesoderm. From in here, we can see this in relatively thin skin. Here again, we can see the dermis, which has the fibroblasts and a lot of collagen materials, and then we have the epidermis, which is the epithelial cells. Stratified squamous epithelium with keratinites on the surface. Now, there is regional variation in the epidermis. It could be thick, like a sole. It could be thin, like the eyelid or most of the body. Here we see it fairly thin in the ear. It could be transparent, like in the cornea of the eye. You can see right through it. Also, it has appendages. Appendages could be a nail. It could be glands. And also, it has projections in the oral cavity whenever you have the tongue, for example. So it gives rise to numerous appendages, hair, as I mentioned. Also, the mammary gland is epidermis or originated structure. Nails, as we said. Apical sweat gland as well, but this is one that marks the territory in animals. And then you have the tarsal gland, which is right up here at the top and at the bottom. It holds the tears in. And the tears themselves, all those come from the epithelium of the epidermis. Now, if we look at thin skin, and it's thin because the epidermis is thin, as opposed to thick skin, thick because the epidermis is thick, we can see a host of things. We can see the different layers: the epidermis, the dermis, and the subcutaneous layer here. Epidermis is thicker here, dermis, and then the fat layers. We can also see in skin the hair follicles, sebaceous glands that we were talking about, blood vessels that project up into here. Epithelium sits on the basement membrane, and the basement membrane separates the epidermis from the dermis, as we can see. So when you pull the epidermis off of the dermis, you see in thin skin versus thick skin, it's really the epidermis that determines whether it's thin skin or thick skin. And you have thick skin like a sole of the foot or on the hand. You ever worked in the garden, you might get a callus. You're developing thicker skin in that region. As opposed to your arm or the belly or someplace, you have thin skin. And I just want to illustrate here that you can use your atlas. The atlas has things labeled for you and identify the different structures in there. The arteries, the veins, the sebaceous glands, the sweat glands, all those can be seen in the atlas images. Now, if we look at abdominal skin, which least specialized and most prototypic of skin, we see the dermis is dense, irregular connective tissue, and the epidermis is above. If we look at thicker skin, we see a thicker epidermis, dermis, hypodermis below, and you can see where the epidermis has pulled off. And whenever this happens, you have the interdigitation. Thicker skin has a greater interdigitation between the dermis and the epidermis than does thin skin. And here we can see that projections of the dermis into the epidermis we call dermal papillae. And then the epidermal pegs, or the reedy pegs, are the epidermis dipping into the dermis itself. So where the epidermis touches the dermis, we call that the papillary region, where you see these projections in through there. And then below that, the dense irregular connective tissue is a reticular layer. Papillary layer, reticular layer. And here we can see the papillary layer projecting up through there. This would be like a sweat gland duct going out through there. And if you look inside these projections, what you will see is blood vessels. So these are the blood vessels that provide the epidermis, which is avascular, with its nutrients. Here we can see the blood vessels here, which are the same as what we're seeing here, which are in the dermal papillae. In addition to the dermal papillae projecting up through there, you can even have a corpuscle. This is a Meissner's corpuscle that is light touch sensor that we have. Dermal papillae, epidermal pegs, epidermis, dermis, as we can see. And then the hypodermis, which is below the reticular layer, below the papillary layer, which is the interaction between the epidermis and the dermis. We have the hypodermis, which is where the fat cells are associated with them. Also, there's a proscenium corpuscles. You see these onion-like things in through there. And then we have an eccrine sweat gland. So this is the one that makes you sweat throughout the body, is the gland that does that. Here's a duct of it. The duct is more eosinophilic or red as opposed to the secretory portion. So we have fat cells, adipocytes, and the hypodermis, and this is a deep pressure detector in through there. So this is proscenium corpuscle, sweat gland ducts, DUCT, and also the sweat gland itself, the eccrine sweat gland, and another proscenium corpuscle, which looks like an onion, but these are like fibroblast cells here, and a little piece of a nerve is in the middle there.
We want to thank the many original sources of the images and pictures that were used in this presentation. We want to thank the original sources of those. So this is the end of the functions of skin, the origin of the skin, the epidermal-dermal interactions, glands and nerve endings in the dermis of skin. Thank you.